Welcome back to another session of MOOC on Information Security, Security Mechanisms and Overview. This module describes about different security mechanisms in computer system. From this module, a learner is expected to achieve the following: understand the importance of computer security, understand the concept of cyber security, get an idea about the different security mechanisms used in computers, and to learn about intrusion detection system. Computer security. As we have mentioned earlier, computer security, also called cyber security, is the protection of computer systems and information from harm, theft, and unauthorized use. Security mechanisms deal with prevention, detection, and recovery from a security attack. Prevention involves mechanisms to prevent the computer from being damaged, while detection requires mechanisms that allow detection of when, how, and by whom an attack occurred. Recovery involves a mechanism to stop the attack, assess the damage done, and then repair the damage. Types of security mechanisms. Network security is a field in computer technology that deals with ensuring security of computer network infrastructure. A network is very necessary for sharing information, whether it is at hardware level such as printer, scanner, or at software level. Therefore, security mechanism can also be termed as a set of processes that deal with recovery from security attack. Various mechanisms are designed to recover from these specific attacks at various protocol layers. The different types of security mechanisms are encipherment, access control, notarization, data integrity, authentication exchange, bit stuffing, and digital signature. Encipherment. This security mechanism deals with hiding and covering of data, which helps data to become confidential. It is achieved by applying mathematical calculations or algorithms which reconstruct information into not readable form. It is achieved by two famous techniques named cryptography and encipherment. Access control. This mechanism is used to stop unattended access to data which you are sending. It can be achieved by various techniques such as applying passwords, using firewalls, or just by adding PIN to data. Notarization. This security mechanism involves use of trusted third party in communication. It acts as mediator between sender and receiver so that if any chance of conflict is reduced. This mediator keeps record of request made by sender to receiver to deal with case of later denial. Data integrity. This security mechanism is used by appending value to data to which is created by data itself. It is similar to sending packet of information known to both sending and receiving parties and checked before and after data is received. When this packet or data which is appended is checked and is the same while sending and receiving, data integrity is maintained. Authentication exchange. This security mechanism deals with identity to be known in communication. This is achieved at the TCP/IP layer where two-way handshaking mechanism is used to ensure data is sent or not. Bit stuffing. This is a security mechanism used to add some extra bits into data which is being transmitted. It helps data to be checked at the receiving end and is achieved by even parity or odd parity. Another method of adding security is digital signature, which we have already discussed. This security mechanism is achieved by adding digital data that is not visible to eyes. It is a form of electronic signature which is added by sender and is checked by receiver electronically. This mechanism is used to preserve data which is not more confidential, but sender's identity is to be notified. Security mechanisms are built using both personal features and technology. Personal features are used to frame security policy and procedures and for training and awareness. Security mechanisms use technologies like cryptography, digital signature, firewall, user identification and authentication, and other measures like intrusion detection, virus protection, and data and information backup as countermeasures for security attack. Just recall the science of writing information in a hidden or secret form, which is an ancient art. Yes, it is cryptography. Cryptography is necessary when communicating data over any network, particularly the internet. It protects the data in transit and also the data stored on the disk. Hope you remember the different types of cryptography such as symmetric key, asymmetric key, and hash function. In the case of digital signature, an electronic signature can be used to authenticate the identity of the sender of a message and to ensure that the original content of the message or document that has been sent is unchanged. Digital signature schemes normally gives two algorithms. One for signing, which involves the user's secret or private key, and one for verifying signature, which involves the user's public key. In a digital signature process, the sender uses a signing algorithm to sign the message. The message and the signature are sent to the receiver. The receiver receives the message and the signature and applies the verifying algorithm to the combination. If the result is true, the message is accepted, otherwise it is rejected. Firewall. We have also discussed about firewall in one of the previous sessions. It is a security mechanism to protect a local network from the threats it may face while interacting with other networks like internet. A firewall can be a hardware component, a software component, or a combination of both. It prevents computers in one network domain from communicating directly with other network domains. All communication takes place through the firewall, which examines all incoming data before allowing it to enter the local network. Functions of firewall. The main purpose of firewall is to protect computers of an organization or local network from unauthorized access. Some of the basic functions of firewall are: firewalls provide security by examining the incoming data packets and allowing them to enter the local network only if the conditions are met. Firewalls provide user authentication by verifying the username and password. This ensures that only authorized users have access to the local network. Firewalls can be used for hiding the structure and contents of a local network from the external users. Network Address Translation or NAT conceals the internal network addresses and replaces all the IP addresses of the local network with one or more public IP addresses. Now, we will move on to the intrusion detection system. Intrusion detection system or IDS. An intrusion detection system is a monitoring system that detects suspicious activities and generates alerts when they are detected. IDS is a system designed to test or analyze network system, traffic or events against a given set of parameters and alert or capture data when these thresholds are met. IDS uses collected information and predefined knowledge-based system to reason about the possibility of an intrusion. IDS also provides services to cope with intrusion such as giving alarms, activating programs to try to deal with intrusion, etc. There are two main kinds of intrusion detection system, a network system and a host-based system. A network intrusion detection system or NIDS enacts intrusion detection across your entire network using all packet metadata and contents to determine threats. Advantages of NIDS are relatively safe from direct attacks as hackers may be unable to trace it. faster than a host-based detection system, and helpful in detecting internal and external threats or attacks. Disadvantages of NIDS are they cannot read or identify encrypted data. Chances of false positive are high and time consuming as it monitors a large volume of data. A host-based intrusion detection system or HIDS enacts intrusion detection through a particular endpoint and monitors network traffic and system logs to and from a particular device. Advantages of a host-based IDS are encrypted data is also accessible, detects anomalies by focusing on systems or devices, can identify both internal and external activities. The disadvantages of host-based IDS are substantial risk of false positives, tedious and time consuming process, and chances of network traffic congestion. Working of intrusion detection system. After data collection, an IDS is designed to observe network traffic and match traffic patterns to non-attacks. Through this method, sometimes called pattern correlation, an intrusion prevention system could determine if unusual activity is a cyber attack. Once suspicious or malicious activity is discovered, an intrusion detection system will send an alarm to specified technicians or IT administrators. IDS alarms enable you to quickly begin troubleshooting and identify root sources of issues or discover and stop harmful agents in their tracks. Intrusion detection systems primarily use two key intrusion detection methods: signature-based intrusion detection and anomaly-based intrusion detection. Signature-based intrusion detection is designed to detect possible threats by comparing given network traffic and log data to existing attack patterns. These patterns are called sequences, hence the name, and could include byte sequences known as malicious instruction sequences. Signature-based detection enables you to accurately detect and identify possible non-attacks. Anomaly-based intrusion detection is the opposite. It is designed to pinpoint unknown attacks such as new malware and adapt to them on the fly using machine learning. Machine learning techniques enable an intrusion detection system or IDS to create baselines of trustworthy activity known as trust model. Then compare new behavior to verified trust models. False alarms can occur when using an anomaly-based IDS, since previously unknown yet legitimate network traffic could be falsely identified as malicious activity. Importance of intrusion detection system. An intrusion detection system can protect the network and computer from a variety of threats. Besides hackers, an intrusion detection system can protect against all forms of malware or internet worms. A network intrusion detection system is specifically created to monitor network traffic, and it will automatically send an alert of abnormal activities. Whether it is a man-made virus or an international hacker, a network intrusion detection system is the ultimate protection against security threats of all kinds. The components of an intrusion detection system. A network intrusion detection system is comprised of three distinct components. The sensor enables it to detect any immediate security threats and is the main component. They usually have a signature database which allows it to identify the malicious activity. The backend is the second component, and it is responsible for alerts and recording any events. The alerts can be sent in a variety of ways, whether it is a database log, email, or console display. Depending on the version, some backend components are able to provide a temporary connection block which prevents the hacker from accessing its initial target. The front end is the last component, which is the user's interface. The user interface allows the user to view any event that the sensor has detected or set up an IDS configuration. The user can also update the sensor and signature databases. All of these components work together as a whole to provide the ultimate protection against hackers or any type of malicious software that threaten network security. It is always said that no network is completely safe. Security mechanisms can be designed to protect against attacks and meet security requirements such as integrity, authenticity, confidentiality, and availability. Using cryptography, we can convert data into hidden form and can transmit over the network. It protects the data in transit and also the data stored on the disk. Firewalls can also be used to provide security by examining the incoming data packets and allowing them to enter the local network only if the conditions are met. It also provides authentication by verifying the username and password and thus ensures that only authorized users have access to the local network. An intrusion detection system or IDS can be used to detect suspicious activities and generate alerts when they are detected. By providing proper security mechanisms, we can protect the data from unauthorized access. I hope you are now clear that the concept of security is of highest concern in an information system, especially those based on network. Hope this session was useful for you. See you again. Take care. Bye.